Hello guys. A bunch of you already likely saw my video. So this is my Game Boy Advance SP, or rather Raspberry Pi inside of one. Just showing a little bit of how it works, insides and a bit software. Maybe I make a guide on Hackaday, maybe not. I will see. So first, this outside you could see there's a power switch, like the original one, but it's working. Got USB-C charging, no fast charging, just regular 5 volts. You have the headphones jack and your volume control, so up and down in steps, I think 2 decibels. The left and right button, no external port because obviously that's not a GBA. The card is actually glued in because it's mostly cut away just to make it look a little bit nicer, so there's no open hole. You can open the back, but then you just see like this, the battery and the amplifier and so on. I will show it later. So, and yes, there's no big modification. Start and select this tactile push buttons inside there. And yeah, the buttons are not made with the original rubber pieces with the conductive plates. It's just push buttons that placed under there. But yeah, so to turn it on, you just flip the switch, and I'll just press it here. It takes around 1.5 minutes. It's a long boot time, but can change a lot. Maybe it can disable Wi-Fi completely in the DHCP program, but maybe it changes. But I'm leaving it right like this right now. Just takes a while. So while it's booting up, I can show you this was my first prototype, or rather my second. The first prototype actually worked. This one was just the idea to put it inside a Game Boy Advance SP. And yeah, it worked from the button, and so it doesn't actually feels better with the buttons than here because of the way the push buttons work. But yeah, just if you can see there's just like this much space I would have left for all the cables, and so this all. There you see some of the boot up screens, and yeah, it just wouldn't fit. I tried it multiple times, just didn't work, and with the hinge and so on, it was even harder, and it's not that comfortable. So you can hear again, boot up screen made partial, also not by myself, but I cut them together, place them together, so I just have more to see before it finally boots up. So already see there's a red light for the power. That's actually not directly connected to the power. It's from the, I'll show you later, the USB, or rather it's lithium-ion charging and boosting circuit. So you see I already booted into Game Boy Advance, just running RetroPie with this different theme. So I have some consoles on here. Just show here Super Mario Bros. Because it's the most simple one. There's still this error code I'm getting because of using a USB sound card, but just software works. Hardware wise, it's mostly finished. So yeah, it would have maybe worked, but to be honest, I really like the feel of this one instead of this more like cramped together. And yeah, I would have had 2 more buttons to exit Y, and don't have them here. I could have made them, but I just left it out for now because anyway, I don't have really games that can run on Raspberry Pi Zero, a normal one, that would need those buttons. So I can just start right here, and then you see it's completely working. I already made a video, so I can play a little bit like here. I was thinking about maybe adding an external HDMI port so you can plug it into TV or etc. Maybe even an AV port, but nothing right now, so yeah, can play pretty simple. I don't have a hotkey button right now, so to close games you would press them together like this. A bit annoying, but can't change it all. So then just turning it off really quick so I can show you the insides. Also, this is yeah, nothing. So when it's turned off and the LED stops blinking, you can cut the power like this, and yeah. So to open it up, I'm actually using the official tri-ring screws. So just get in here. It's a bit bright. Second, can I put it? Light control is a bit bad, sorry. Yeah, and generally sorry for the quality of the video. I don't have a better quality webcam right now. I got a phone, but to hold it the whole time is a bit annoying. So I just used the webcam, but it does the job. I still have some pictures online. I will link them under this video for the insights, especially for those who maybe want to build a similar thing. I don't intend to make a whole guide because, as I already said, this was more of like, yeah, maybe this fits there. Yes, the parts that I have left maybe work good there. I don't have like a whole list of parts that you can just buy off Amazon or so. More like parts I had laying around. Yeah, it's not perfectly made for others to build, but yeah. So opening it up, already some parts fall out, the power switch and the two levers. So flipping it open like this. So the battery is still not secured because part of the case I needed to modify later, so just didn't glue it down for now. So what you see right here is the insides, obviously. So here, so the blue part of here that's mostly covered up is the actual display. It's TFT, I think 2.8 inches LCD with a driver IC. You can see it right here, not so readable. ILI 9341, the best one that works with the driver I have. Can show you later on the software bit. So the two PCB perf boards here are for the buttons I made. I just soldered them on the front and soldered wires on the back directly to the GPIO pins to make them work via GPIOnext. I have a big heatsink on the 0 to make it a bit more cool. Here's the SD card. Then here's the amplifier for the speaker I have right here. This speaker is from an old PS4 controller that broke. It's surprisingly loud for the size. I had another speaker right here. This one worked actually a bit better, mostly for the volume, but it sadly was just a little bit too big to fit in the hole, so I just left it out, and this one worked much better. Also, I hear the volume controls, just two simple push buttons with these three cables here, the purple, blue and green one. Those three work here, and also over GPIOnext you can write commands. I will show them you later. So yeah, here this is the power wire, so plus pole, this minus. Those two wires are for the USB data lines to the USB sound card down here. And this is the audio line because the headphone jack's down here and it's a switching one, so if you plug your headphones in, the speaker goes out. So on the bottom here you can see there's a battery, obviously a 1000 milliampere, gives me around 2 hours and 20 minutes. With normal gaming, maybe SNES or higher demanding titles will take it down to under 2 hours. You see the rest of the GBA game card, mostly cut up just to make it look good, but I needed the space. This is the power, the lithium-ion charging and boosting circuit. It has like those 4 LEDs. I can push the button, so I see, yeah, mostly nearly empty. You don't see the state of the battery exactly, but when it's near ending, like around 10 minutes before it shuts down, the last one starts blinking. So through here you just see it blinking, and you know, I have like 10 minutes left. Here's the USB sound card that goes with these 3 cables here for right, left and ground into the headphone jack. And as I said, this mono, it's here stereo, and because I only one speaker, I merged it through 2 1 kilo ohm resistors to a mono signal, getting it up here into the amplifier. And yeah, here's the power switch, like there. That's just engaging with this this groove in here. Just goes on like just grabs it like here. Focus. Yeah, let's see it kind of. I'll take pictures later so you can see a little bit better. But yeah, that's basically the insides. You see it's not very clean, and I didn't make any custom PCBs. I could maybe have done that, but I was just too lazy and didn't want to expand even more. Actually, I was working on this project I think since 2020, because I already said I had multiple versions, multiple prototypes. Some worked, some didn't work. And yeah, this one finally worked for me. I'm pretty happy to finally have it in my hands. So just putting it back together, you take the shoulder buttons, flip this around carefully, just pressing a bit. I think I need to open this right here so I can push it like this. Don't forget, get it together down here. It's a bit annoying to put it back together. Don't open it that much, so just do it like this. Yeah, and then pressing on the sides and then just taking the screws again. There. Oh. Get in there. Shoulder buttons back on again. It's a hassle to put it back together. Maybe if I had done a bit more clean job, maybe would have worked, but maybe would have been easier. But as I said, you don't actually need to open it that much. Maybe if you have like a problem, it doesn't turn on, so a cable disconnected or something else. But even regarding data, so files on the SD card, if you don't destroy your SD card, you normally just corrupt it. You can just use the integrated Samba server of Raspberry Pi. So just go on your PC, drag the files over there, if like ROMs or so, and yeah, just let me screw it back together. This screw in here. Yeah. Different bit for the last one, because that for some reason all are tri-wings except this one screw. That's normal Phillips head. Just get it in there. So, and then push the battery in to the side. Then just close it up. So yeah, that's where the insides. So now I'm gonna get onto the on my PC and show you the rest of the software. So hi there, I'm back again. So just to show you first, if you want to access your Raspberry Pi, you just need to go // then type in, I think just Raspberry Pi works, but I'm just doing it with IP address. So just using my local IP address, and should be try again, // So yeah, now it's working. So you have your BIOS, like your GBA, all the BIOS of the systems, config, ROM and splash screens, mostly ROMs. If you just need to export ROMs, put on a new one, and yeah, that's should be automatically activated. So have your putty open. So just show you what you need to do to set up like I have. So first up, I installed the driver for the display. You need to know which one of which display driver IC on your chip you have,
and then you need to just show it. So first up, I used the driver like this from GUI, the FBC ILI 9341 library, and so here there's just a bunch of read up, or as actually explained, but I'm just explaining it too. So to install it, you see you need to clone this this library. If you have done that, you just list it. You see you have the FBCP library folder here. You just go to there. So in here are just a bunch of files, and you already see the build alt folder that I have. If you don't have it, you shouldn't have it if you made it first time. You just make a new folder. Show folder with mcal directory. Also so mcal dir and just the folder name I already have it. So then you move into the build folder. So in here right now there's the files are already made, but normally I don't think I have it. Oh, you're right, I have. You need to make write this command. So you write cmake and then all the things you want to customize for the driver. So you need to say which chip you have, as seen on the side right here. You see you need to all the chips that are supported. You need to select which one you have and then just write on. And what's important, before every of those like commands or configs, you need to write the minus, then the command. If you leave out the minus, it just doesn't accept it and just ignores whatever it there. So here, right here, you have the GPIO data control. So you need to connect your pin to your display to the GPIO pins over the SPI line. At least my display does, and it should be if you're using similar displays like this. Just let me show you how I connected it. So if you just get like here, you have your normal SPI lines, MOSI, MISO, clock, and what I did, to make it a bit more clean, I used the power line right here. I used the MOSI, MISO, clock and ground. This one is all reserved, you see, and then GPIO 5 and 6 for either DS, so data and reset pin. So I have just like these 7 pins in a line, except for this one it's ignored. And I just recommend to you do the same. It's just a bit cleaner for the pinout. So you have like your TFT, you need to say yes, I'm using 5 for data or DS pin. Reset is pin 6. You have your clock divisor, that is how fast the Raspberry Pi is talking over the SPI data line, with what frequency. It has to be an even number, and yeah, safe number should be around like 30, and you just can go down from there, test if it works. If you have like artifacts, lines, or it crashes, doesn't even work, then you should go a bit higher. The best one I got working is 6. For this driver you might have, even with the same display, same driver, all that, even different numbers, just is like that. So try around, but I've got like 60 FPS with even 10 or 12. Then lastly I just wrote d statistics, again with the minus right here, equals 0, because there normally, if you don't write that, there's like a small like FPS and frequency and just a bit data for testing. I recommend you leave it off or on right on or run for the beginning, just to test out if your display works, and for the final version of the program just leave a 0. What you also need to do is, if your display is flipped like mine, so I put it on the top, you need to write minus d display. The d is always at the beginning, like this, underscore rotate underscore 180 underscore degrees equals on. So it just flips the display on, just doesn't only flips the actual display you see, not the HDMI image or so, because this grabs just your HDMI settings. And you could also write some use configuration like right here, like here break aspect ratio, and what I nearly used a battery pin, so it shows like a little battery icon. And yeah, but this is how I wrote my program. If you press enter, it starts writing then, and if it's when it's finished, to finally make the program you just make with CMake, you need to write make minus j. Just a second. So I'm back again. Just noticed the Game Boy is blinking right now, so the battery is actually nearly empty, so I'm just charging it right now. So in the end you just write make j, and it just takes like a minute or so. When it's finished, you can list again. You see I already have it, the FBC driver here, and that's finished, but you would need to activate it every time you start your the Raspberry Pi up. So what I did is I just wrote it into the etc/rc.local file. This file here is like auto start, or you can write things in here to automatically start when your Raspberry Pi boots up. You see here sudo home and then the whole library, and here's the program we just made. So it starts up automatically when your Pi boots up. And what's important is to make this and symbol here at the end. If you forget it, it waits to start the program and doesn't continue, waits for it to end. So if it's not working, that would be good in that case, because it can boot up normally. But if you forget to remove this, to place it here, so it would be like this, then your Raspberry Pi wouldn't really start up. So it would start the driver and would stay there, because it would be waiting for it to end, and because it doesn't end, nothing would work. So yeah, just exit it. I'm not saving because I made some changes. Would be working fine. What you then need to make is you need to configure the config file under root. So just go right here, config.txt, and what you need to enable is HDMI group at mode, like this. The CVT mode, so you have your pixel. In my case it has a 320 by 240 display, 60 FPS, and right here you need to activate force hot plug, so it always activates HDMI even if there's none connected, so the driver can grab it over HDMI. The rest needs to be unactivated, so yeah, there shouldn't be. Yeah, the rest is just normal. You don't need to change anything right there. So that takes care of the display. Now to get to GPIONext. Now to install GPIONext, you need to also grab the GitHub files. Just open it for a second and can you show. You normally need to get this command right here. So this, and it's already cloning. Stop. I hope I just didn't destroy it. Hopefully not. So you need to clone it, and then you would need to activate. So if I just go into GPIO, very big. I know I need to move up a second. Oh, okay, wait. I think. Oh no, all good. So I move up 2 times. So I'm back in this directory. Now go to GPIONext folder. Right here you see some files. To install it, you just bash the install file right here. It's installing. Maybe you need to reboot. And after it's installing, it says you can configure it. Just show you how. You can also just skip the configuration and do it later via GPIONext and then config. The screen takes a couple of seconds. This screen shows up, so you can configure commands and your joypads. So mainly joypad 1 for your player. Then you go in here. You select how many D-pads or joypad sticks you have. I have 1. Then you select all the buttons you have. I have a start button, select A, B, left trigger and right trigger, like this. No. Then you press enter, and now it asks you to hold those buttons. So I hold up, I hold down, left, right, I hold the start button, select A, B, left, and right. So it's finished. Get here, then those buttons should already be working. What's important, you just saw which pins it connected. You need to write those down when you're doing this. So maybe take a screenshot, maybe just write them down individually, because we need them for later. Then you go to commands for the volume control, and then I already have those two. You need to edit the commands. You would normally make them. So you have your name. I'm holding the button right for volume up, like this. You also need those pins too for the volume control. You see, this is my command. I'm go through the. You just need to copy it. Just what's important, you need to know which over what you are outputting audio. Like if you're using, similar to me, an audio card, a USB audio card, I'll show you what you need to change to make the the USB sound card working. But if you're using like normal, what it means more, you're using Raspberry Pi 0, so maybe you're using the over GPIO, but I recommend just using an audio card, just works, and you're not going to use the sound card, the USB port anyway. So yeah. So what you need to do is, in my case, I set it up so the sound card is number 0. Then you need to know set the speaker, and set per click, just change it the volume by 2 decibels. And yeah, just copy and paste this command or write it up and press enter. I don't need to make another. And for here, you just write the same thing, just instead of a plus 2 decibel, you write a minus decibel. And yeah, after that, you just exit it. And this is what it's important before you restart your Raspberry Pi. To make your sound card work, you need to tell the ALSA mixer for it to work. So you write this, go edit this, run file, press enter. Normally should be empty, and you write those 3 lines. So you make the USB audio as 0. Oh, I just see this is a just my error. The internal one should be 1, and then just the slots, just save it and exit. And now, what I had a problem with, you might not, but just in case, if you're using GPIONext and the driver I just mentioned before, there is a problem, because the driver itself does the GPIONext is a bit, I would say, lazy or complicated. So instead of just asking all the buttons or GPIO pins that are configured as buttons, it normally just checks every singular GPIO pin, which obviously clashes with the driver because it too uses the GPIO pins. So to deactivate or just tell the GPIONext which pins it needs to use, just write GPIONext, then you write set pins like this. Give me a second. Need to go here. Tell it like this. This is one of the flags. So, and then you just write what pins ever you had before, like 7, 8, 10, with no spaces in between, just commas all along. And when you finish it, press enter, and it saves those buttons. And before I forget it, you just need also for the for the display driver, what I forgot to mention, go back into just go like this, go back into the config, because it's important that you deactivate the internal SP here. If this is like this and your driver doesn't work, it's because that's activating the internal SPI driver. You need to deactivate it because the FBCP library has its own drivers, and if you leave those on, they're crashing in between, and the display just doesn't work. So leave it uncommented with the hashtag. Exit it. I didn't change anything, so no. And yeah, so after if you just reboot it, it should be working, and that's a yeah, course introduction to how you make it. Maybe I make a guide, but yeah, if you have any questions, write them down below, and yeah, thank you and bye.